Good evening, everybody, and welcome to the Soil Challenge Week, which we at Pasture for Life run in collaboration with Soil Mentor. We're really excited. We've got quite a number of events happening this week, including some training happening tomorrow and the day after, for which Abby Rose is coming up to Scotland. And in fact, she's on her way on the train just now, and I'm going to have to disappear at about 8:30 to go and collect her. So yeah, very excited to have lots of soil related activity going on this week. So this webinar is just an opportunity to have a chat about soil health. I've designed it so that I'm going to be delivering some of the sessions. So it's going to be a little bit of delivery, but I'm also really keen. And I'm just going to ask you all to mute. Sorry, Rob, I just muted you because there was a bit of feedback. If you could just make sure you're all on mute, that would be great. And it will be great if you can then maybe come in and have a chat later on. But just for now, whilst I'm presenting or talking, if you could stay on mute, that would be amazing. Thank you very much. And yeah, so I've designed this so that I'm going to be doing a bit of delivery. If you have questions at any point, please do raise your hand. Don't do it in real life because I won't be able to see you because I'll be presenting. So do put up your virtual Zoom hand, or you can just unmute if I haven't seen it and just interrupt and say, oh, quick question, and ask your question. You're more than welcome to do that. You can also put questions into the chat, though I might not pick them up as quickly. So you'll just have to bear with me. If I miss any questions, please do just nag and nudge, because it may be that lots of chat happens and I miss things. So yeah, delighted that there are so many of you here. I've just seen Carrie saying that she's here from Land Advice Manager from a wildlife trust and who is slightly soil obsessed. So I'm sure there's going to be many of you who know loads more about soil than I do. So I'm very excited for this to be more of a discussion as we go on through the next 55 minutes or so. So it is a dip into the soil, as it were. We're digging a wee hole, a figurative hole, to have a chat about soil, but please do come in with your questions as we go through. So bear with me as I get my screen sharing sorted out. So I'm hoping that you can all see Introduction to Soil Health in presentation mode. The only person I can see is, well, Rob, maybe can you just let me know if you can see that?
Yeah, we can see that. Lovely.
Amazing. That's great. Sorry, I'm still admitting people from the waiting room. So if I'm a little distracted, it's just because I'm trying to do admin and presenting all at the same time. My historic teaching experience is starting to come into play a little bit. So yes, Introduction to Soil Health. This evening, we're going to be looking at what soil is, how it functions, and what makes healthy soils, and a little bit about management, which I'm kind of more interested in maybe. So if I get too management heavy in terms of how we actually manage for our soil health, then, you know, give me a nudge and direct me back to actually talking about soils. But it's amazing stuff. It's a phenomenal world under our feet, and it's very exciting that so many people want to know more about it. So as I said, we're going to go through an overview of what it is, how it functions, what makes it healthy, and how we can monitor it. So thinking about the fact that we are working with Soil Mentor on this project, and how you can use their app to help you to monitor soils. And if you don't have the app, there are lots of things you can do that Soil Mentor have made available open source, so that you can learn how to monitor your soils without having to get the app. Because what we actually really all care about is how do we have more resilient, healthier soils, which lead to more resilient, healthier farm systems. So, and actually at the very start of this, I do just want to say a big thank you to Pen Rashbas, who has developed so many amazing graphics for these presentations that I've been doing over the last year or so. And I am just so grateful that we have excellent quality of materials. So yeah, very quick thank you to Pen. And just to credit, if you don't see who these are credited to, then the majority of the time it is Pen. So this is, as you can see, a bit of a cross section through our soils, and everything from dung beetles and their larvae to earthworms to roots, and then this amazing kind of area at the top of the soil on the soil surface where so much activity is happening. And so you can see that when we talk about soil, although there are these aggregates, these mineral particles that are in the soils, actually there's a whole load of other stuff in there as well. And historically, since the kind of Green Revolution, post Second World War, Soil has been very much thought about from to some extent physical, but also very much from a chemical point of view. And we're now kind of exploring soil in much more around its kind of biological elements and how the microbiology within that soil contributes to the role of soil in absorbing water, cycling energy, cycling nutrients, and cycling carbon. So as you can see from this image, there's loads of microbes, there's fungi that are all operating at different levels. And some of those fungi are mycorrhizal, which means that they are interconnected and that they are connected in and with and around the roots. So the rhizos, rhizo is kind of essentially means roots. We've got invertebrates, so we've got our dung beetles, we've got larvae, we have got flies, we've got fly larvae, all sorts of different insects, as well as worms. And worms generally come in 3 different types. The ones that live right up on the top surface, which are our litter worms that are helping to break down and pull some of that leaf litter into the soil. And then we have worms that operate at different levels, so like a mid-level worm and then the much deeper burrowing worms as well. So it's not just, oh, there's worms or not worms, or oh, we've got larvae or not. There's such complexity, as I'm sure you're all aware. And then there's this magical place within the soil, the rhizosphere, which is the soil that directly interacts with and is around each little root nodule. Now, the image at the bottom makes the rhizosphere look massive. As we know, on some plants, it is really chunky. On a dock, for example, or a thistle, or on chicory, you get a really, really hefty, chunky taproot. And you can very much see, if you've got healthy soils, the soil actually sticking onto that root, which we would call the rhizosheath. But we also have these tiny, almost unable to see with the naked eye roots that are all acting in the same way. They've all got a very important job to do, and they're connected with fungal hyphae, which are bringing nutrients in. We've got plant exudates, which are the kind of sugars, glomalin, which is coming out from the plants, and microbial metabolites, which are also entering the roots. And all of these are working together to enable healthy plants, healthy soils. And bacteria have a really important role to play there, particularly in relation to legumes, which are helping us to fix nitrogen, because it's actually that bacterial interaction that is creating the nodules that are helping to fix the nitrogen. And you might hear people talk about bacterially dominated soils or fungally dominated soils. And I guess what we're looking for, and those of you that might have gone through the Elaine Ingham Soil Food Web course, who probably should be delivering this session rather than me, if you are here, will know that, you know, the kind of optimal level, or the ratio that we're looking for, is 1-to-1 bacterial to fungal. But there are going to be different types of soils present in different places, and always kind of shifting maybe away from some of those bacterially dominated soils to more fungal dominance is going to help us, particularly in terms of soil health, energy cycling, nutrient cycling, and so on. And the aggregates are all the bits that are kind of the broken down bits of stone and rock that are going to come together and be stuck together thanks to the microbiology that actually aggregate and create the kind of the crumbly blocks, if you like, within the soil. And you'll know that if you dig into the soil, you'll find kind of sometimes quite blocky, chunky, aggregated soil that is quite compacted within the blocks, and then they kind of in big chunks break apart, which would suggest that there are some issues in that soil that might need management to fix them. But we also would see really lovely chocolatey, cake crumbly kind of soils, which would demonstrate a much higher porosity and potentially soil carbon level. And that porosity is really important for air and water permeability. And any of you that have read my favorite book on soil, Nicole Masters For the Love of Soil, will know that she very quickly in that talks about actually it's air that is the most important thing that we need to get into our soils. Quite often people think it's water, that water is the key to all life in our soils. But any of you who have got wet, boggy areas that might be dominated by rushes in your fields will know that there's plenty of water down there. The challenge is the lack of air. And that's where we see plants like rushes coming in that have actually got hollow roots that help to get air down into those anaerobic, airless soils. So air is really, really important. And we can help create permeability for air and water by creating healthier soils. Bear with me as I just check that everybody who's meant to be here is. Yes, brilliant. There's no one in the waiting room. Okay, so moving swiftly onwards, the role of soil, obviously, as we all know, is that it is creating and supporting the cycling of energy. So we've got solar energy coming in from the sun, plants are absorbing that carbon dioxide, they're using carbon dioxide from the air and the water from the soil to build carbohydrates. Those carbohydrates are exuded through the roots to field soil organisms, and then soil organisms release carbon dioxide through respiration. So quite often people talk about, we need to store carbon, we need to capture carbon and hold it in the soil. And I would just urge caution there, because actually what we want to do is to cycle carbon. Yes, we want additional carbon dioxide that doesn't need to be in the air, that has been created predominantly through the burning of fossil fuels. We do have the ability to hold that within soils and to lock it away once it's in there. But we also need to remember that the carbon cycle is a really important function of life, and without it, we wouldn't be able to exist. So we want carbon to cycle in and out of the soil. That's normal, but we predominantly want it to be a sink as well. So we want to be able to cycle more in than we have going out. And we know that carbon dioxide is going to go back into the atmosphere through decomposition of plant matter, through those root exudates and the soil organisms breathing that feed on them. So we know that that's going to happen. What we don't want to do is release additional carbon dioxide, for example, through excessive ploughing, through excessive poaching, trampling, those sorts of things, and creating bare soil. So if we have bare soil, and the most extreme would be, dried out peatlands, then we are going to be losing that carbon dioxide. Okay, I'm conscious of time. We've got loads to get through and I'm already 15 minutes in. So very quickly, just to talk about the role of dung. Obviously, I'm sure many of you, because you are here on this Pasture for Life webinar, you're going to know that livestock are key to our beliefs and how we think about soil, and their dung is incredibly important in providing that nutrient cycling capacity within our pastures. So yeah, just a quick shout out to the dung beetle and all the excellent other inverts that are living in there that are helping to pull nutrients from the surface level deep down into the soil to engage with all of the other invertebrates that are, and microbiology that is below our feet. I realize that I'm whizzing through this, but I did say that this was an introduction to, but you can see here we've got this fantastic kind of blown up particle of soil. So within this bit, imagine that this is a crumb or a clump of soil that you've just pulled out of the ground, you've got in your hands, and it's a lovely chocolatey brown. And if we were going to zoom into that, then we would see all of these different things taking part and existing within that clump. So we've got our micro aggregates, which are microscopic little collections of plant and fungal debris, clays, silt aggregates as well. And amongst all of that and holding that together, we've got particulate organic matter. And that isn't just static, it's constantly being decomposed by fungi, and that is, is part of that energy cycling. And wrapped around all of this is this mycorrhizal fungi, which is this network, fungal network that exists below the soil, which helps to pass messages and exchange nutrients between different plants, between different biological entities under our feet. And amongst all of this is bacteria and viruses, and that's all really normal for all of that to be in the soil. It's, sometimes we think about bacteria being a bad thing or viruses being a bad thing, but actually they all exist quite happily in harmony to some extent within the soil. And it's only when maybe animals or we are exposed to these and we are potentially immunocompromised, or we've got other health issues, or we're within a certain context, that they become problematic. But these do exist in the soil all of the time. And then around all of this, we've got organic binding agents and kind of glues and glomulins that are holding all of this together. And then outside of that, we've got this pore space, this space that is really important in our soils. And the soil isn't just about all these aggregates and they're just a kind of big clump of it. What we don't want is compacted soil. We want that pore space that allows that air, that water to circulate. And any of you, as I'm sure many of you have, having to deal with horrendously wet weather either 2 weeks ago or this weekend, will know that having soils that can act like a sponge and hold that water together is really, really key. I'm just going to flick through some of these because otherwise we will be here for hours rather than just the allotted time. But you can see here a blown up version of that normal, healthy soil with air and water that can pass through as part of that clean air and clean water cycle that we want in our healthy ecosystems. And then we've got compacted soil with no moisture, no air. That means that we're going to have dead soil that actually can't grow very much. And that's where we end up predominantly with just a growing medium, where we then rely on artificial inputs to try and help grow plants, things like artificial fertilizers, synthetic fertilizers, herbicides, etc., growth regulators, so that we're just essentially using that soil as a bit like a petri dish. What we want is soil that in on and of itself is a living, breathing ecosystem, and that can do all that hard work for us, so that we're not having to pay to put additional things in. As I said, I'm just going to whiz through some of these because they're less relevant to our conversation. And again, you know, further emphasis on the role that all of these different levels within the soil play in regulating carbon and nitrogen cycling. There are always going to be carbon dioxide and nitrous oxide emissions from soil. There's also going to be nitrogen fixation, and there's going to be sequestered and stored carbon and nitrogen within our soils. We have a world that is out of balance. We have too much carbon dioxide in circulation. Soils, as we know, can hold a lot of that, but there is inevitably going to be some emissions from decomposition, from the cycling of energy. We just need to think carefully about how we manage that and how we try and store more than we release. Okay, so we know that within our soils, we've got all of these different aspects that we need to take into consideration. And what the research is telling us is that plant diversity drives and stabilizes agroecosystem function. So that basically means that if we want biomass production, e.g. the growing of plants, if we want carbon storage in our soils, if we want water storage and infiltration, we want immunity against fungal infections, insect attacks, etc. If we want these public goods, as you might term them, then we need to make sure that we have got a diverse microbial community, and we get those because they're associated with different plant species. So the more plant diversity we can have in our soils, we can then potentially determine the greater soil microbial diversity and function that is present underground. Now, this can promote all of these functions, such as plant growth. So not just the fact that we're producing biomass, but actually maybe it's growing quicker, or different types of plants are able to cope with stressors like drought or excessive water. That the nutrients are cycling. We're able to actually access nutrients that are in the soil through the plant into our animals, so they're healthier. We've got healthy decomposition, the breaking down of dung, for example, and that mitigation of greenhouse gas emissions, because we're not releasing excess carbon dioxide and nitrogen oxide into the air. Actually, we're holding it into the soil where we need it to stay. And we also know that soil microbial diversity, so the more diverse the microbial community as a result of that plant diversity, means that we can have better soil aggregation and water permeability. And this is brilliant research that has been going on for some time, particularly Andy Neal at Rothamsted Research has been doing some fantastic work on this. He did a brilliant talk for us in the Pasture for Life research group a couple of years ago now, and it was just fascinating. He's done talks at Groundswell, so I'd really recommend looking him up. So that's Dr. Andy Neal, and he has explored the interesting, I guess, phenomena that they were finding, which actually showed that the greater the porosity in our soils, so those gaps that we're letting air and water through, the greater that porosity, the more complex the genetic profile of the microbial community in that soil. So if we've got healthier conditions, actually we get more interesting, more complex, more adaptable microbial communities that can actually work harder for us to keep our soils healthy, our plants healthy, therefore our animals healthy, or us healthy if we're eating the plants directly, for example, in the different crops that we might be growing. So there's such a connection here between what's going on above ground and below ground, and how that relates to us and to the animals that many of us are looking after and that have stewardship for. Okay, I feel like I maybe need to pause and just see if there are any questions. So just bear with me while I just jump back into Zoom and see if there are any questions in the chat at all, or if anyone has a question that they want to just shout out.
I haven't seen any questions, Nikki.
Okay, thanks, Rob. And no one's shouting out? Brilliant.
No hands up.
Fab. Thanks for being my number 2 in this, Rob. Really appreciate it. I'll have to get you a bottle of something as a thank you. Oh, I can see there's something in the chat. I don't know if that's... Oh, brilliant. Joyce has shared syntropic agroforestry as a practical implementation of these principles. Thank you so much for sharing. I love that when people are able to share their additional learning in the chat. It's a really great way to... You'll all end up with loads of tabs open at the end of the session from all these brilliant links that I'm sure you're going to share. Okay, so we've talked about complexity. And then one of the things that people talk to us a lot about is carbon, soil organic carbon, so SOC. And so we need to be able to, particularly when our customers, if they're buying meat from us, or if they're buying other products, if we're farming not just meat, but we're farming all sorts of, dairy products, or we're growing plants in market gardens, or we're growing crops, often the public or the rest of the supply chain wants to know about, well, what about carbon? What about, well, the bottom line is it's the building block of all life, but we also recognize that there is this increasing requirement for farms and land users to store and sequester carbon in the soil. So one way to think about that is that actually, as I said, carbon is this building block of all life. But soil organic carbon stability is affected by the physical properties of soil, such as the aggregate turnover, the chemical stability. So mineral, clay, or silt type soils have different capacity for holding soil organic carbon. So, for example, a clay soil has really high capacity for storing carbon and for actually enabling carbon to attach onto all of the kind of jaggedy edges that you'd find in a clay soil. But we also know that clay soils can be difficult to manage because if they get very wet, they can become very compacted, or if they're dry, they can crack and break apart. So clay has great potential for soil organic matter storage, but at the same time is very, very tricky to manage. For example, in silt or sandy soils, we can often really struggle with that as well. So we can see low organic carbon content. So it's not useful to kind of compare farm to farm. I would say if you're going to take soil organic carbon measurements on your farm, and there's some really great companies that will come out and do that for you, or you can dig your own holes and you can send it off for analysis, that it's more important to actually look at what the changes that are going on your own farm. So thinking about, between every 5 years, taking soil organic carbon or taking your carbon, soil carbon measurements, and looking at how your management is changing those readings rather than thinking about what is everyone else doing. It might be useful if you have a neighbor, if you're in a cluster and you've got very similar sorts of soils that you might want to compare. That might make sense, but definitely don't kind of get hung up on, oh, well, you've got 12% and I've only got 3%, because there's so many different factors that are going to affect that. As you can see here, we've got environmental effects, chemical stability, physical properties, microbial properties. There is so much going on how we're managing our soils that are going to have an impact on that soil carbon sequestration, both at a higher level in the soil and much deeper. And I guess the bottom line of this is that there is so much about this that we don't know. And one of the challenges is that policy and market drivers are kind of making us as farmers, as food producers, make decisions about our farming based on soil carbon without any of us having the ability to really understand it, measure it accurately across our farms consistently, or be able to kind of take responsibility for that for ourselves, because we're always relying on other people to do that measuring for us. So, I would say that the conversation about soil carbon, and often people say to me as head of research at Pasture for Life, oh, well, tell me, how do I prove that mob grazing is good for soil carbon? Well, the bottom line is we don't know. We don't have those answers. What we do know, though, is if we can have lots of roots, if we can support roots to be healthy, if we can have a high level of biomass above and below soil, then we are going to be able to help our soils to be more active in how they engage with all of the different processes that is keeping our soil carbon in the soil. Okay, I can see there might be a couple of questions in the chat. So there is a question from Colin. Has there been a number put on the volume of carbon nitrogen sequestered by grass or mixed plant crops? I'm not going to go into a huge amount of details about this because we do have limited time. I really recommend looking at Joel Williams' work, who's been doing some really interesting research, looking at that in much more detail, and also looking at the different diversity of crops or grass mixtures and how that relates to how much carbon dioxide is coming into the plant and is being processed. But no, Colin, there isn't a kind of single number that says this is how much carbon or nitrogen is being sequestered by grass or mixed plant crops. It's so dependent on the system. And because the way that research often works, these things are done in isolation. So it's very difficult to say, if you grow this plant or this collection of plants in this type of soil, this is how much carbon you can sequester, because we just don't have the answers at the moment. But I would recommend checking out what the work that Joel Williams has been doing to look into that in a bit more detail and to see some of the examples from some of that work. There's a question from Carrie about how can the SFI soil option help engage farmers and landowners to improve and manage their soil health. Be interested to hear others' experience with that. I'm not going to answer that, Carrie. My policy, I'm based in Scotland, and my policy knowledge and experience is better suited to Scottish policy. However, if there are others in the meeting who want to jump in with that in a moment, then yeah, we can definitely open up the conversation for there. And Manda has just shared Joel's website, Integrated Soil. So thank you very much for that, Manda. Okay. I'm not going to go through this in too much detail, but just to say that obviously soils have an important role to play in water cycling. When it rains, the water hits the ground. If it hits bare soil that is compacted, it's just going to run off. If it hits grassy plants, then it's going to be able to infiltrate, and then we have much deeper percolation that will then interact with the mineral layer deep within the soil. I'm sorry if you can hear some rumbling in the background. It's one of my dogs. It is not my stomach. So we want water to be stored in the soil profile. We don't want it to run off into watercourses. We want to slow the flow. We want to hold water in the land, and we want to treat our farms as sponges. You know, when water falls, particularly most of us now will have experienced a couple of years of, you know, weather that seems to be all over the place. Sometimes really dry and hot, sometimes really wet. We go from these extremes. In order to mitigate the impact of these extremes, what we need to try and do is hold water so that when it's really, really wet, it doesn't cause flooding downstream. And when it's really, really dry, we've got that water stored from earlier on in the season. And there's that brilliant quote, isn't there, from, it's probably Gabe Brown or somebody, who was asked, you know, how much rainfall do you get on your ranch? And they said all of it. So it's about capturing all of those water droplets that hit the farm. There's a really, really nice example on the Soil Mentor blog that Niels Caulfield, who, if you don't know, is a consultant and trainer in soil health, who gives a really, really nice example of how long it takes to infiltrate 1 inch of water into these two different areas of the field. So they did an infiltration test, and then next to where the infiltration test was done, they dug up a section of the soil, and they've saved here that which has the 80% rooting depth. So on the left hand side, we've got the field margin, so it's kind of a rougher area near the hedgerow. And that's a lovely, I think, cocksfoot plant at the top. And you can see all of those lovely roots that are coming down deep into the soil. On the right-hand side, we've got a reseeded pasture, predominantly ryegrass, perennial ryegrass. And you can see that the roots are probably half that, if maybe less, than the plants on the left. And so the infiltration of that 1 inch of water was 7 seconds on the left-hand side. That's nothing, 7 seconds. So imagine an inch of water coming into that contact with that grassland. Within 7 seconds, it's gone. On the right-hand side, you can see it's more compacted. You can see that there are fewer there's fewer roots. 20 minutes it took for that water to get in. Now, if you've got consistent rainfall coming down onto your farm and it's taking 20 minutes for some of that rain to get through, all that's going to happen is runoff, and you're going to be losing then nutrients from your soil as they are taken away by the water that is running off the soil, because the water's got nowhere to go. And what we want is those nice deep roots that are helping that water to infiltrate. As I said, I'm going to probably very quickly get onto management of grass beyond the soil itself. So I'm not going to stay too long on this, although this is where we get to see nice pictures of cows. But you know, animal impact has a significant role to play in terms of soil health. And I don't think really we can talk about healthy soils without talking about healthy plants and healthy animals. So we definitely know that we need that dung and urine from livestock to be able to help feed our dung dwellers, which are helping to feed the soil. We need microbes that respond in different ways, both to dung, but also to soil dwellers, but also to saliva from plants that are decomposing. And obviously livestock have a role to play in transporting seed and in trampling and in rubbing and breaking and grazing as well. So animal impact has a really important role to play along with all of the other management considerations we can take when we're thinking about healthy soils. I'm not going to get hung up on mob grazing or rotational grazing, because I could talk all night about that, and you come to hear about soil health as opposed to grazing management. But if you are interested, we can go through that in more detail. But I do just want to say that this fantastic diagram does highlight that point around, if we've got continuous grazing and we've just got animals there all the time that are overgrazing and reducing the length of those routes, then we do tend to see challenges around water infiltration. We create rest in the system, then we start to increase microbial and mycorrhizal activity. We get longer roots, we get greater water infiltration. And when we have really long rest periods and adaptive grazing that is changing according to the needs and the conditions that are around us, is helping us to manage 4 very particular outcomes, then we see an even greater increase in microbial and mycorrhizal activity. And we see much, much deeper roots. We see much more diversity, both above and below ground, and much healthier systems. So, I think the key thing to take away from this is that soil, like us, also needs time to rest. And I think sometimes we forget about that, and we think of soil as just holding up animals, but actually it's a living thing. The roots have an integral part to play. If we graze our grasses too much, we're going to lose that root mass below the ground, and we're going to reduce the soil's ability to do the job that we need it to do in a climate like ours in the UK, where we need it to be able to cope with a lot of water, but also increasingly cope with those drier periods of weather, as we saw in last summer's drought. So yeah, just to say that, like us, we all need a rest, we all need a break, as does the soil, as do the plants. They also need that rest, not just during the winter, but during the time at which they're growing. And I think that's really important. Sometimes we think, well, our pastures are going to get a rest over winter, but that's the dormant season, when they're not really doing much anyway, and they've gone into dormancy and they're not very active. We need to create rest for our soils, for our plants during the growing season. Now, if you are, some of you I know are in Cornwall and Devon, and you lucky devils, you get basically a year-round growing season. For those of us up in the northeast of Scotland, less so, and varying shades of that in between. But we do need to remember that rest during the growing season is really, really key, because that's where we get the opportunity for those roots to really get deep into the ground, and for that nutrient cycling and that water cycling to really start happening, and to create that connected porosity, that network of airways under the soil, to help us to capture carbon or to store carbon once it's been brought down into the soil, and also to help us with water infiltration. I can see that there is a question from Colin. How long is too long to leave pasture without animals grazing before microbes and fungi disappear? Is there a maximum limit in mob grazing? That's a really interesting question, Colin. And I would say within a non-brittle or a temperate climate like ours, rest is a really important part. It's one of the most, kind of powerful tools in that toolbox. And you'll be able to see that there will be the longer you leave a pasture, for example, we're going to get a change, we're going to get a shift in the dynamics. Now, if we think about in a country like the UK, generally we're seeing succession from pasture would always kind of head somewhere towards scrub and then woodland. And so I don't think we would see microbes and fungi disappear, but we might see different communities appearing if we were leaving something long enough, for years, for example, and the whole kind of community changed. I think as humans, I'm going to go on a little bit of a tangent here, but I think as humans, we've forgotten that, the systems and the cycles that we are engaging with are much longer than the year that we often think about. But, there are plenty of people who are grazing some pasture where it's appropriate once a year. So that's a 364 to 360 day rest. And actually they're getting great benefit from that, and they're able to defer that grass and only graze it once in a year, and it's serving a purpose for them, and it's highly diverse. It all depends on what you're managing for, but I think the maximum limit in mob grazing, not really. It depends on what you're managing for, what your context is, and microbes and fungi won't disappear, but they will just change, and the community will change. It's an ever shifting and evolving community. I would say that if we're looking at kind of intensive root crop systems, like if we're thinking about potato growing or carrot growing, then those are the kind of systems where we do start to see the biology significantly disrupted because of the amount of churn and change within those soils and the way that they're having to be managed to produce and grow root crops at the sort of scale that we expect to see them in the supermarket, for example. So, these are conversations. I'm predominantly talking about pasture. Obviously, within other cropping or arable or field scale vegetable operations, it's going to be a very different picture. But thank you for the question, Colin. And yeah, maybe there'll be other questions coming in as well as we carry on through. But yeah, as I said, short grazing periods and long rest gives us recovery. And we know that overgrazing has implications for the plant, for the soil, for rainfall resilience. And you can see this excellent diagram really demonstrates that. So what we're looking for is those nice long roots. And, you can graze right down to the growth point in that plant. So the second picture in from the left, actually, you could take that down further as long as it was in one hit through a high density grazing system. The challenge that we have in overgrazing is when we graze a plant before it's really recovered. So, for example, that second plant in, if we were to leave that animal, that cow there, to come back and take another chomp before that plant has recovered, and then another one and another one, that's where we start to see the roots dying off to feed that plant, to try and keep that plant going, because actually it's got no leaf left to act as a solar panel. So I think, there's a lot of debate and discussion around total grazing or a third, and a third, skimming, and it's really dependent on your context, what you're managing for, what you need to achieve from your pasture, the type of pasture you have. And I think that kind of adaptive multi-paddock type approach is going to serve us far more than saying, I'm grazing in a leave a third, trample a third, graze a third, or I'm, grazing it right to the ground every time, because actually there are situations where any of those are going to be tricky to manage. But actually, if we want a more adaptive system to cope with the challenges that the climate and weather are throwing at us at the moment, then, taking more adaptive approach to our grazing management is one way we can do that. I'm not going to linger here too much. But yeah, I guess to say that, rest is a powerful tool. And we know that trampled leaf matter feeds the soil. There is some discussion and debate predominantly from Jim Elizondo or Haim Elizondo, who kind of talks about trampled leaf matter not really having as much of a role as we think it does in the production of humus, but actually that it's the kind of fatty exudates from roots that are doing that. But I think that sometimes he runs the risk of oversimplifying something that is very complex. So I think there is definitely a role for trampled leaf matter, not necessarily just into the soil, but also creating protection and armor, particularly when we get very heavy downfalls of rain, but also creating habitat for other surface dwellers and different insects and things as well. I think something that quite often we talk about, or we need to create more space to talk about, is, poaching and compaction. These are probably, from a pastured point of view, the biggest challenges that we face when we're thinking about soil health. And we can all get it wrong at times. And quite often we might look at this and, the farmer that sent me this photo and then sent me another photo to demonstrate that actually a decent rest and it wasn't as bad as it looked. And I think sometimes some of us look at this and go, oh God, that's really terrible. Others look at it and go, well, that was a wet day when the cattle were left in that paddock 12 hours too long. And there's still plenty of green left there, and if we give it enough rest, it will come back, it will be fine. I think what we want to make sure we really avoid is that constant day after day after day poaching. You particularly might find it around gateways, for example, if animals are coming in and out, around water troughs. That's where your poaching then leads to compaction, which then leads to your kind of symptomatic presence of things like docks and thistles, and other deep tap rooted plants that you have a role to play in the ecosystem to try and smash through that compacted layer of soil to help that water, to help that air get in there. So, anyone who knows me knows that I have a real issue with kind of driving over fields. And quite often we think about compaction only coming from vehicles. And you can see here, for example, when a tire goes over the soil, there's going to be pressure downwards. That's potentially going to have an issue around compaction on the soil, which is why it's important for us, I think, if we are going to drive on fields, to try and stick to tracks, drive in the same place rather than just all over the place. We forget actually that the weight of the vehicle, even though we might have tires that are able to kind of really spread that pressure out, it's still going to have an impact on the soils which weren't designed to kind of hold this stuff up. So, you know, I think that there is a role for us to think about in terms of how can we reduce the risk of compaction through unnecessary presence of vehicles, for example, on our fields, particularly, for example, in wet weather when they are much more vulnerable. And again, we can see here, if we had a lovely soil on the left-hand side that had lots of air and water and the solid in there, on the right-hand side, we've got the same amount of soil, we've got the same amount of kind of, you know, solid dirt, if you like, but we've got less, a bit less water. We've still got some of that water getting in there, but a hell of a lot less air, which means we have anaerobic, we have lifeless soils. And if we drive over our soils, that's the first thing that's going to go. They're going to break down the soil, will kind of push down into those air gaps, and that's what leads to compaction. And this is a really great video, and I'm happy to share the link from this in a follow-up email, which won't be until the end of the week, I'm afraid, because I'm delivering training for the next few days. But this is some of the fantastic work that I was talking about when we were hearing from Andy Neil at Rothamsted, showed us this kind of diving into a soil micropore. And you can see here, this is a screen grab from this video. This is what it looks like when you're in the soil, this kind of burrowing. And these are these microscopic kind of capillaried, if you like, spaces within the soil that's where the carbon is able to be stored in the kind of edges and the rough parts of around the edges of these micropores and into these pores. And it's where the soil, where the water can pass through, and obviously also air. So these porous soils are so important in terms of soil health. And again, just to reiterate that point, if we've got good structure, if we have got macro and micro aggregates, we've got good pore structure that is connected. It's that connectivity that is so key. If we have an effective root penetration, which creates that connectivity within the soil, we get efficient water infiltration. We have a mycorrhizal network that can be extensive because it's got places to go, it's got spaces to fill, and we have high oxygen permeability. We also then get increased soil carbon storage. We have enriched soil biodiversity, greater metabolic activity. So if all of the microorganisms in the soil are happy and healthy, then it means that they can metabolize energy much more efficiently and effectively. And it means that soil bacteria is able to break down methane to carbon dioxide, which means that we don't have methane release, we've got CO2 release. So these methanotropes are able to do that around the soil surface. And this is an area of research that is, you know, significantly under research, and we really hope a lot more money will go into that in the future. It means that we have an effective nitrogen cycle, and if we have effective nitrogen cycle, we reduce the need for synthetic nitrogen input. And it also means we have lower nutrient leaching, so our rivers and our streams and our waterways are kept much cleaner. So healthy soils versus degraded soil. In a degraded soil, we can still grow a plant. We might still have some plants, we might still have a few fungal fruiting bodies above the soil, but generally we're going to have greater emissions, and we're going to have a higher number of pathogens, and we're going to have higher nutrient runoff, leaching and emissions. So we're always aiming for this top line rather than the bottom line there. Okay, I'm going to just stop. Oh, and as I said, sorry, yes, we had the image that I shared earlier, and we have a similar one here on the left. Rest is a powerful tool, post-grazing damage and recovery just 7 days later. And if you give that a good month, then actually, you know, we're going to see a significant improvement in the soil structure after that initial post-grazing 1 day. You know, those animals were left on there 12 hours too long on their daily shift because it absolutely poured with rain, but rest is able to help fix that for us. And again, the picture on the right is the one I started off with. And you can see a couple of months later, I think it was 4 or 5 months later, we then have the picture on the left where it's recovered really well, plenty of trampling. This farmer uses daily moves, quite high density stocking, moving multiple times a day actually, and we're able to see that that rest has enabled that field to recover, because this is not the same as the kind of poaching where you're getting that around gateways every single day, animals up to their hocks in mud. It's just a very quick issue around, you know, animals being on there a little bit too long. Just give it that rest and it will be absolutely fine. And there's a great video actually that Rob Havard, I'm not going to play it now because I haven't set up optimal sharing, sorry, through Zoom, because I completely forgot there's a video in here, but Rob does a great video about that, about leaving animals too long and then coming back a few months later and actually, you know, all will be well. Okay, so yeah, just to highlight that, you know, we've got brilliant roots that nature's pretty good at adapting to any given niche. Natural processes are always moving us towards succession, and healing is a natural process. And roots that you'd find here on docks, chicory, thistles, for example, have a really important role to play in that. Whether we want to see them on our fields or not is another debate. Personally, I'm a big fan of a dock. I think it has a fantastic role to play, but we can get into that discussion in a little while. Okay, stop there. And I'm just going to open up for Carrie. Thank you. You just said you've got to go. Maybe you've gone already. But thanks for joining us, and just kind of stop so that I can grab a glass of water and a breath and see if there are any questions. And no question is a stupid question. So please, if there's anything I've gone through too quickly and you want me to clarify, please just shout, put your hand up, or put it in the chat. I'm more than happy to have some discussion now. Everyone's being very polite and doesn't want to ask a question.
I'll come in, Nikki, so you can have a glass of water. And well, there you go. One's come through. So Jill's asked, are there idiot guides to soil sampling?
Oh, good question, Jill. I'm going to come to that in a second, actually. So Rob, did you have a question? And then I can come back to Jill's.
Yeah, so if you come right back to the comment you made earlier about the rushes and stuff like that, if you inherited a pretty wet, very rushy field, what would be the very first thing you would do with it to try and set off on a better foot?
Yeah, well, I think it really depends what you're managing for, because it might be that actually it's best suited to be a pond. So if you are up for having a pond on your farm, maybe that's the perfect place for it. So that's one thing. And I think it's, determining what it is you actually want to manage for. Rushes have a really great role to play in creating shelter, particularly time. Any of you that are lambing maybe early in the year in wet, windy places will know that the clump of rushes can be really, really helpful. If I'm guessing that from your question, Rob, that maybe the ideal on that field might be to have lush pasture that can hold lots of animals on it. And let's pretend that that is my management outcome. So I have historically taken on fields that are pretty rush dominant. And I tend to treat them like any other pasture. So that would be daily moves with cattle, and just treating the rush and the grass like any other, just treating it all as if it's one plant and grazing across that. This isn't a quick fix. It does take time. But what I've found is that what tends to happen, if you imagine a lot of the fields that you might see that are rush dominant, you get a tall rush, and then you get like billiard table next to it of grass, right? Now, the only plant that's going to thrive there is the rush, because it's the one that's being left to thrive. So the idea that if I just leave the animals on there a bit longer and they might start eating the rushes, it's not going to happen. They're just going to continue to overgraze. So what I wouldn't do is leave animals on there longer. But I would just treat a rushy field as with any other field. If it's really, really rush dominant and there's not going to be much feed value in there, you need to think about what animals you're putting on at what time of year, because you don't want to put, newly calved lactating cows, for example, onto only rushes. It's not going to be great for them. It's not going to be great for their calf. So there's an animal health and welfare element to think about. But generally, if you've got a bit of a mix of grasses and you've got a bit of a mix of rushes, but it's rush dominant, to try and treat it all so that you go graze and rest, and potentially think about grazing it when the rushes are just coming through. So kind of during actually the early spring, late winter, or into the back end in the autumn, quite often you will start to see growth happening from the rushes at a different time to the grass. So that might be a good time to graze them. But what I've seen is, by taking that kind of graze and rest approach, is that the grasses that are in and around the rushes start to dominate. And you can almost see the rush start to kind of become weaker and is surrounded and covered and has so much grass going in and around it that you're creating the kind of competing plant. That grass is able to compete with the rush because it hasn't been hammered and overgrazed. There are challenges. George has just asked a question. Other than rest, what are some practical things you can do to increase soil porosity and reduce compaction? Don't drive on these fields. If they're wet and soggy, don't drive on them. Rest is a really key one, as I've already said. I think optimal grazing, so having some grazing depending on the type of landscape that you're working in. I think grazing is really important. Remember, our grasslands co-evolved with grazing herbivores like ruminants, horses, etc. So having animals grazing on them is really key. And that might be another one actually with rushes. Horses really are quite happy to eat rushes. I've been mob grazing horses for just over a year now, and it's phenomenal, kind of their ability to just thrive off what we might think as being not suitable for ruminants, for example. So yeah, thinking about changing the mix of animals you've got in there, maybe goats, maybe horses, seeing if you don't want to have your own, borrowing some in from somebody, as long as you're maintaining biosecurity protocols, that might be a good way to just kind of create the nudge or the shift in the system that is enough to start changing the community of plants. Because remember, everything is all about trying to, that succession all of the time. So creating a nudge, creating a shift, doing something a bit different can sometimes just be enough to kind of create that change in the system. I don't just want to talk about rushes, and I can see that Cindy has a hand up. So Cindy, do you want to come in with your question?
Yeah, thanks, Nikki. Thanks for all that speed dating with soil health. I suppose in theory I understand it all, and then it's like, how do I make a bridge between that and actually having a plan for my farm? And so in simple terms, it's like I can get grants. I've done a sort of baseline soil survey, but I can get grants from SFI, but it's hardly worth it. And then, you get so little money, and then Devon Wildlife Trust will do me a soil plan, but it probably costs me a lot more than the grant. And so I'm going to be out of pocket. And so then basic rules are, I want to increase the plant biodiversity. I want to keep the traffic off, especially when it's wet. And I want to be careful about my grazing plan. And grazing plan, I've got some rough idea, but like, how do I just like make a grazing plan for myself with what I know, and then try and make that work and not monitor my soil because it's too expensive, and just hope it's going to go according to that? And, is it just a general direction and sense that you're recommending? Or do you think that there's something more precision about it? Like the mob grazing gets super precision to the point of, I don't know, I can live like that kind of a thing.
Yeah, I mean, that's interesting. Thanks for your question, Cindy. I think that's a really good point. And I used to, when I first started mob grazing, I was like evangelical, precise, they had to move every day. And now I'm like, well, it depends what I'm managing for, and it depends where I'm managing and what I'm doing. And I think I've become a lot more relaxed about what adaptive multi-paddock grazing looks like for us with our livestock. So I would always recommend, so I went and spent some time with somebody who wanted some help with the grazing plan in the summer. And I said, right, let's just go month by month, because she couldn't cope with the idea of like every day knowing where those animals were going to be. That's 365 decisions that she was going to have to make. That was a lot of brain effort. So we said, okay, well, let's just loosely, in January, where do you want your animals? And actually it was difficult to start with January. So let's start with May, when we know there's loads of grass. Where do you want them? So I would suggest, I don't know if you're in one of the protected areas where we've got a FIPL project, our pasture and profit projects running. If you are, try and join one, because we have some really great mentors that can help with that grazing planning.
I'm in Exmoor, just below Exmoor.
Yes, okay, brilliant. So I think we have some FIPL projects now happening in Dartmoor and Exmoor. So
what projects?
Yeah, the application's going in this week, Nikki.
There we go, Rob. So we are.
What's a FIPL project?
Yeah, so we're working in protected landscapes to deliver mentoring support for pasture farmers and anyone really that's interested in managing their grasslands. So Cindy, I've got your email from when you signed up for this session, so I'll make sure I put you in touch with the right person. And if anyone else is interested in any of those projects, just make a note in the chat and I'll try and get the right person to follow you up. But yeah, so a mentor would be able to help you with that. But basically, I would suggest make some sort of a plan, because actually it's not in the plan, it's the planning that makes the difference. The act of just thinking about it and trying to work out where animals are going to be, and where you want them, because actually, so for me, I plan, we try and plan where we want them for calving, where we want them for bulling, and where we want them in the first when it inevitably snows. And then we also want to think about where else in the winter might we want shelter. So you can fill all those blocks in first, where you want them for tupping, where you want lambing, whatever it is you're doing, and then fill in the gaps. And you're going to have them moving around when the grass is growing quickly, and you're going to move them more slowly when the grass is growing slowly. And though, that's basically the kind of underpinning principles. So I would definitely recommend, we'll get you in touch with somebody if we get that project up and running in your local area who can help you with that, Cindy. And I don't know if you're already a Pasture for Life member, but membership, there's definitely brilliant. Might be worth asking on the forum if anybody has a grazing plan that they could share who's nearby to you. That might be a good way to go. But yeah, there are also a number of consultants who you can pay to get help doing your grazing plan. The other thing you could do is holistic management course. So if you haven't done that already, you could do your holistic management fundamentals with 3LM. And there's also then a holistic grazing module where they help you to do that grazing plan, that 365 day of the year plan. So if you were going to spend money, I think that's probably where I would recommend spending that cash. Now we've got 2 minutes left. I want to just see if there's any other questions. Manda's asked a question about methane digesting bacteria in soil. I'm not going to go into detail, but I think that's a really good point, Manda, that yeah, it's not just about like the methanotropes that are on the kind of active near the kind of surface in those healthy soils. But yeah, there are methane digesting bacteria in soil as well, but you need to have kind of healthy functioning soils, but also taking into account that, you know, if we're emitting methane into the air, we also need to be able for air to get into the soil to then potentially break that down. So the air mix that has some methane in it, we have to have porous soils if we want our methane digesting bacteria to actually kind of cope with that or manage that. And then we do have challenges around that anaerobic conditions where we have methane emissions. So it's very complex, and we've got 1 minute left, so I'm not going to say any more about that. But just seeing if there are any other questions. Cindy, yes, I keep my cattle out all year round, but you know, it's all about what you're managing for and whether that's right for you or not. So yes, it can be a challenge. Are there any other questions? Is there anyone else with a hand up that I haven't seen? No. Okay. Well, folks, I'm going to draw to a conclusion. Sorry, big breath there. I feel like I've talked and talked and talked, and I'm sorry if I've just kind of, you know, if the experience has been like standing in front of a fire hydrant. That's what my husband says it's like when I get going on one of these. I just kind of throw information out. As I said, it was an introduction. Oh, soil sampling, Jill. Yes, you had a question about soil sampling. Idiot guides to soil sampling. So I recommend, if you are interested in kind of, well, Soil Mentor for one is a brilliant app. But if you don't want to get the app, you can go onto their website and it gives you loads of guidance about all the different ways that you can visually assess your soil and the different soil sampling approaches you can take. If you want to do a soil sample that you then send off to a lab, there's some really great resources. If you just do like soils, I think ADAS do a really good, so ADAS, they do a really good idiot's guide to like how to take a soil sample and send that off if it's something you're wanting to get lab tested. But any labs that you use will also give you guidance on how to take a soil sample. If you're wanting to do like a visual assessment, or you just want to see your rooting depth, I really recommend going onto the Soil Mentor website and have a look at the soil test area. In fact, if you go, soils.vidacycle.com, but if you just look up Soil Mentor and then go to soil tests, you've got, they tell you how to do an earthworm count, legume nodulation assessment, rooting depth, soil insect score, how to assess your rhizosheaths, percentage of bare earth, carbon stocks, infiltration rates, and then loads of other tests like how long it takes for dung to break down, and sward density, and compaction measured through a penetrometer, and all sorts of different approaches that you can, soil pH, and how to do all of that with some broader kind of testing advice on where to do that and how to take your samples. So Soil Mentor website is the #1 place to go if you want to understand how to take those. And would you do a video guide from the places you visit for that first visual assessment? Are you asking me to do a video? All of the Soil Mentor guidance has videos on it, which is really helpful. So yeah, I would really recommend them, much better quality than I would probably do, which would be me dropping my phone in a cow pat or a puddle. So yeah, there's if you go onto the Soil Mentor website, there's brilliant videos. Mostly it's Annie Landless being fantastic, telling us all about the soils. So you get a real kind of, you can pause it, think about it, go back, watch it again, and get guidance that way. Ladies, gents, I'm going to stop there because it has gone past 8 o'clock. But thank you so much for all coming along. And yeah, really, really glad that so many of you were able to join us. The link will be available on the Pasture for Life YouTube channel soon. And if you're interested in any of the things I've talked about, please drop me an email, Nikki, Nikki, at pastureforlife.org. And if there's anything that you wanted more information on, then do just drop me an email anytime. Thanks again for joining. I hope you all have a lovely rest of your evening.